Hello everyone, in this video we will see the first function of dynamic memory allocation, that is malloc function. So dynamic memory allocation is the process of allocating memory space during execution time, that is at run time. This allocation technique uses predefined functions to allocate and release memory for data during execution time. So if the storage requirement is not fixed, then dynamic memory allocation technique is used. Here we can decide the size when we are executing the program. So we can increase or decrease the size of variable. So when we require extra memory, then we can add extra space, and suppose we want to delete the space which we don't need, we can delete that space also. So for adding and deleting memory space, there are 4 different functions that can be used in dynamic allocation. So just like we include the header file stdio.h to use predefined functions printf and scanf function, dynamic memory allocation functions are predefined in the header file stdlib.h file. So all the functions, that is malloc, calloc, realloc and free functions, are already present in stdlib.h header file. So now in this video we will see the first function, that is malloc function. As the name given, M stands for memory and alloc stands for allocation, that is memory allocation. So this function is used to allocate memory dynamically, that is at the time of program execution when the required memory is not fixed. So here, depend on the size of bytes given by the user, this function allocates the memory block in the memory. Suppose user wants 20 bytes of memory, then by using malloc function, block of 20 bytes will be allocated in the memory, and it also returns the address of first byte of that block through the pointer variable. Now we will see the syntax of malloc function, which is already declared in the stdlib.h header file, that is void pointer, then malloc, and in brackets size in bytes. So here size means how many bytes of block we want to allocate in memory. Malloc is the name of function and the return type is void pointer, which returns the address of first byte of block. So if you see the return type, instead of using data types like int, float, the return type is void. So why the return type void is used? So basically void is a generic data type and it can be converted in any data type later on by using typecasting method. The return type void is used because we don't know at the starting malloc function is used for which particular data type. So that's why it is used with the return type void. Once we use the malloc function, we will see easily why void is used as a return type. Now we will see how we can use this malloc function. So this is the syntax of using malloc function. So here ptr is a pointer variable which is used to save the address of first byte of memory block. So suppose we have created 10 bytes of block, then ptr will hold the address of first byte. Amalog is the name function, and in brackets size is the number of bytes we want to allocate. So this amalog returns the value void which we have discussed already. But to store this value into pointer variable ptr, it has to be converted into appropriate data type. So depend on data type of ptr, we have to mention the data type which is used before the malloc function. So if pointer variable ptr is integer, then data type star should be int star. So this will convert the value written by malloc function which is in void type into integer data type. We will see one example based on this. So here we have declared one pointer variable of type integer. Then by using malloc function, we will allocate block of memory. So we have written 20 in the brackets. That means malloc will allocate 20 bytes of block in memory. So here malloc will return 20 bytes which is of type void. So our pointer variable is of type integer, so that value returned by malloc function which is of type void should be converted into integer. So that's why we have used int star in brackets. This will convert the void type written by malloc function into int type. Now this int value will be saved in variable ptr. So now ptr will hold the starting address of memory block. But the size of integer data type is depend on compiler. Means few compiler takes 2 bytes for one integer, few takes 4 bytes for one integer. So how much bytes require for integer is depend on compiler. So suppose compiler takes 2 bytes for each integer, then in this example we have allocated 20 bytes for integer. That means 2 bytes for each integer, which is 10 integer values we can save in memory block. And suppose compiler takes 4 bytes for each integer, then in this example we have allocated 20 bytes for integer. That means 4 bytes for each integer, which is 5 integer values we can save in memory block. So all this allocation is depend on compiler. So to overcome this problem, instead of declaring size, we can use size of function to get the exact memory needed by particular data type. So the same example we can return in this way. So here exact 5 integer values we can save in that block. So size of function gives the size required by the integer no matter which compiler we are using. It will allocate 5 value to enter in the memory. So suppose compiler takes 2 bytes for each integer, then size will be n into 2, that is 5 into 2 equal to 10. And suppose compiler takes 4 bytes for each integer, then size will be n into 4, that is 5 into 4, which is 20 bytes. Now we will see one small program. So first we have declared 2 header files, that is we have included 2 header files, hash include stdio.h, this is for using printf and scanf function, and stdlib.h is included because we are using Amalog function. So this is our starting, that is void main. Next we have declared 3 variables, that is I is for repeating for loop, and to get the size, and then star ptr, that is pointer variable. Next we have printed one message, that is enter the number of integer, and in n we are storing that value. So basically we are taking the number of values we want to allocate the memory. Next, that is ptr, and in bracket int star, then malloc function, and in bracket n into size of int. So that means by using malloc function we are trying to allocate memory space for integer, and the size will be depend on the value of n. Means suppose if we give value of n as 10, then 10 blocks will be allocated, and starting address of that will be initialized to variable ptr. So here size of function will gives how much space is required to store a single integer. So that's why size of, and in bracket int. So whatever the size required depend on compiler, whether it is 2 bytes or 4 bytes, it will be multiplied by value of n, and this value is in void, which will be returned by malloc function, and that value will be converted by using typecast, that is int star, and that value will be saved in ptr. Next we are checking by using if statement whether ptr is equal to null. Means sometimes even by using malloc function there is chance that memory is not allocated. There are many reasons, maybe memory is full. So for that first we have to check whether memory is allocated or not. If memory is allocated, then we can use. So for that we have to check whether ptr is null or not. If ptr is null, that means memory is not available or memory is not allocated. So here if ptr is equal to null, then condition is, if the condition is true, that means obviously memory is not allocated. So it will print the message that memory not available, and we will stop our program here only because we are using this statement, that is exit statement. So this indicates that it will exit our program. Suppose this condition is false, that means memory is allocated by using malloc function. So now we can use memory allocated by malloc function. So here we are taking one for loop, and in that we are trying to insert the values. So here this loop will repeat starting from I equal to 0 till nth value, that is till I is less than n. It will repeat this for loop. So here we are just trying to enter integer values, and if you see, we are storing the value into ptr plus I. So we haven't written any address because ptr plus I will automatically give the address. So that's why instead of using ampersand symbol, we are just using ptr variable. And ptr plus I, that means we are taking address at the first, that is ptr. Suppose ptr is 1000, so 1000 plus the value of I, that is 0, that will be considered, and the value which is entered will be stored on that address. That is on 1000 address, the value which is entered will be saved. Next, this will repeat this loop till condition is true, and in next loop we are printing the value which is stored in ptr, that is by using the address. So star and in bracket ptr plus I, that means we are printing the value which is stored in that address. So now we will take one example. Suppose we have entered the value of n as 5, and then by using Amalog function we are trying to allocate the function. Suppose the memory is allocated, that means 5 blocks will be allocated for this particular, and suppose the size of integer is 4, that means starting from 100 till 1016 this memory block will be allocated. So total, suppose integer required 4 bytes, then 4 into 5, that means 20 blocks are reserved, 20 bytes are reserved for this particular block which starts from 100, and in ptr the address of starting block, that is 100, will be stored. Next, we are using for loop, so in that we are trying to insert the values. So at starting ptr address, that is 1000 plus I, that is 0. In 1000 the value which we have entered will be saved. In next time the value of I will become 1, and even I is less than n, that is 1 is less than 5. This condition becomes true. So we will enter the second number. So here ptr plus I, that means 1000 plus 1, and data type, that is integer, requires 4 bytes, that means actually it is 1000 plus 4. So 1004, on that address the next value will be inserted. So this is how that particular variable or that slot works. ptr plus I means what? The value required by integer. So 4 bytes are required, so that means 1000 plus 4, that is 1004, and on that address the next value will be saved. So suppose we have entered 5 values, so on 1000 20 will be saved. On next address, that is after 4 bytes 4, that is 34 will be saved. After that 4 bytes, that is 1008, 15 will be, and then 1012, 12 will be saved, and in last 1016, 7 will be saved. And similarly in the next for loop, that is we are trying to print the value stored in that address. So star ptr plus I means what? First address, that is 1000, and there 20 is stored, so that value will be printed. Next time ptr plus I means what? I is actually holding 4 bytes, that is of type integer, so 1000 plus 4, that means 34 will be printed, and same next 15 will be printed, then 12, and lastly 7 will be printed.